Banu, working as an assistant professor, AI and DS department, SNS College of Engineering. So in the upcoming series, we are just seeing like what is game theory and what are the different process that is involved in it. And now in the optimal decision in games, we have seen like what is min-max algorithm, and we saw how the tic-tac-toe problem could be solved and all. In the continuation of those topics, now it is the next topic called as an alpha-beta pruning. Now when you take as an alpha-beta pruning is one of the concepts that is related with optimal decision in games. Okay. Now in this alpha-beta pruning, we will be taking the different conditions that is being involved. One is alpha, next is beta, and the next condition that is being involved is alpha should always be greater than or equal to beta value. Now in this process, alpha beta pruning is something like pruning is the word that you will be cut off or shutdowning, or you will not be using the useless branches or the decision that is being involved in it. Now in this alpha beta condition, you have alpha value as minus infinity and beta value as plus infinity. Now when you take this node, in the previous class we saw how min-max algorithm was solved, right? Same process is involved in this, but it will be involved with the alpha beta values. We will be taking the terminal values. First we will assign the values of alpha and beta. The alpha value will be defined as minus infinity and the beta value will be assigned as plus infinity. Okay. Now we will see what is the maximum value between 1 and 2. First we will assign the alpha value as 1 and beta value as infinity. Then we will check for the next node, that is I. When we are checking the next node, now which is the maximum value? It is 2, right? So the alpha value is 2 and beta value is equals to infinity. Now when you move on to the next node, that is B, you will be defining again the alpha value is minus infinity and beta value is infinity, right? Now when we are seeing the different terms, that is 2 and 5, you will be assigning the minimum value. Now when you assign the minimum, initially you will be having the D node as 2 and E node as without any kind of value, right? Now when you initialize with it, the alpha value will be minus infinity and beta value will be 2. That is why, because you will be taking the minimum value between these two processes, that is beta value equal to 2. Now again you will be backtracking the node in the next node, that is E. When you take this node, you will be having the alpha value as minus infinity and beta value as 2. Why? Because when you traverse a node from higher order to lower order, you will be defining the same order as alpha and beta. Now when you compare the alpha value, you have to assign the alpha value and that should be a maximum value, right? When you compare 5 and 7, first you are assigning the value as alpha equal to 5 and beta equal to 2. Now when you go to the next node, you should check the formula, like it is alpha is greater than or equal to beta. When you see that 5 is greater than or equal to 2, the condition satisfies, so you will not traverse to the next node, that is called as K. Now when you again backtrack it, now the alpha value will be minus infinity and the beta value will be 2. Now again you will go to the node called A. You will be assigning the value of alpha equal to 2. Why? Because you have two nodes called B and C. When you compare these two nodes, you have only one value as 2. So you will be assigning the alpha value as 2 and beta value equal to infinity. Again when you traverse back and that is down as C value, to find out the C value, next you will come to F. In that F value, from higher order when you come to lower order, the value of alpha and beta will be the same, right? Now when you see the complete process, you will be having 0 and 1. Okay. Now when you are updating with the alpha value, 0 and 1 is lesser than 2, right? So the same process will be there and you will be retaining with the same values as alpha and beta, that is alpha equal to 2 and beta equal to infinity. Now when you traverse in the higher order, that is node called C, you will be defining the values alpha equal to minus infinity and beta equal to infinity. When you compare these two nodes, the values will be as same, right? Now the alpha value is 2 and beta value equal to 1. Now again when you traverse down, the value of G, you have to check like the alpha is greater than or equal to beta. Now the condition satisfies, so you don't need to traverse in the downwards nodes. And again when you go to a process called A, you will be updating the maximum value of alpha, that is alpha equal to 2. Now what is the beta value? The beta value will be taken as the minimum value. You will be updating the minimum value of beta equal to 1. So this is how the alpha beta pruning is made, and the process of how the alpha beta pruning and the methodologies are being implemented. Now in this you will see like what is this alpha cutoff. Alpha cutoff is like it may be found that in the current branch the opponent can achieve a state with a lower value for us than the other achievable in the other branches. So generally when you take a value of alpha cutoff is something when you have to take the alpha value, the other values will automatically be cut off and it will never explore the other branches as we did in the example, right? Now beta cutoff is something when you are going for when you are about to search, or when you are about to find the beta value, you will take the beta value, and if it is not necessary for you to traverse back again, you will cut off the beta value and the nodes will be done with it, right? Now we will see we have seen the same process of how the alpha beta is being explained, and what is the process that is being involved, and how you should do the alpha beta pruning, and what are all the methodologies that is being involved in it, and the complete process, right? So this is the process of how alpha beta pruning is done and the different methodologies that is being involved. So if you have any doubts, you can feel free to just comment in the comment section, and in the next video I'll be meeting you with a very different topic called Monte Carlo research. Fine, thank you as of now.